Okay, so what we're going to do here in this, we're going to go over, we're going to continue on with the 2.5, 2.9 notes. We're going to start here at numbers 14 through 19 on how to simplify values of I to higher powers. So I, remember, is this imaginary unit. It's equal to the square root of -1, but I'm just going to say I equals I, because we're going to put everything in terms of I, or a number. So who can, you guys, what is I squared? Uh-oh.
-1.
-1. Very good, Nate. Okay. So then this next part we haven't covered yet. So we're going to look at I cubed. Sam, you need to pay attention to this. I cubed is, we can split I cubed into I squared times another I. Do you guys understand that? Hey, can you please be quiet, please? I'm also making a video right now. So this is the same thing, right? You guys all see that? I squared means I times another I is the same thing as I cubed. So then what can you write? What is I squared equal to? -1 times I, which is just -I. So I cubed simplifies, is equal to -I. What about I to the 4th?
-I squared.
The negative square root of -1.
Well, I to the 4th I can say is equal to I squared times I squared,
It's just 1.
which is just 1, because this is a -1 times a -1, which is a negative times a negative, makes it a +1.
Does that mean that all odd numbers?
You're tell me when you get the pattern, okay? Because yes, you're on. I can tell you're already on track on figuring out how this is going to work. So I to the 5th, if we break everything down into multiples of I to the 4th and then look at what's left over, this is where you're going to want to get to. I to the 4th times what to get I to the 5th?
-1.
I.
Just another I, right? Because it'd be I to the 1st, and those you'd add those exponents. And so I to the 5th is equal to I to the 4th times I. What's I to the 4th?
I.
1.
1. So it's just 1 I. This will be this. Is that what you were saying there? That'll just equals I. What do you think you're going to get when you do I to the 6th?
-I.
So I to the 6th. So if I write it as I to the 4th times I to the what?
Oh, it's just 1.
What would it be? What
I
I
to
to
the second.
no, what I to the 2nd, which is that's 1, and what's I squared? What's I squared?
-1.
-1. So what's 1 times -1?
-1.
-1.
Oh, so the pattern is going to be -1. No, -I.
I
Yeah.
negative.
Start from the top.
-I.
I, -1, -I, 1, I, -1, -I.
Yeah. Yeah. So there's a pattern here. If you're watching this video, you've got this one. This is I, and then you have -1, and then -I, and then 1. And then I to the 5th has an extra I after, like I to the 4th, and then there's one more I, right? So that's going to be just I, because the I to the 4th is 1. So you're going to look for like how many factors of I to the 4th go into it, and then how many extra I's there are. So I to the 4th times I squared is going to equal I to the 6th. So I to the 6th is the same thing as I squared, which was back up here at -1. I to the 7th is going to be I to the 4th times I to the what?
3rd.
Yep. I to the 4th is just 1, and then I to the 3rd is -I. So -I. Yep. What's I to the 8th going to be?
1.
1. Very good. So there is a pattern. It's I, -1, -I, 1. I, -1, -I, 1. But you're not going to want to have to work that out all like forever, because I'm going to ask you to simplify things like I to the 20th. That's not too far down the list. You could work the pattern through and get to I to the 20th. But do any of you have a shortcut to figure that out?
Wait, I said 20.
I believe it'd be I.
Yeah, negative.
So
Wait, no, I meant negative I.
It's something with
well, okay. I to the 4th, think of how you can write I to the 20th. The rules of exponents is something you need to know to do this. Yeah, Yen? If I take I to the 4th and I raise it to the 5th power, what is that? What is I to the 4th to the 5th power? What do you do with those exponents? Oliver, do you remember? Sam?
Was it like adding them or something like that?
No, it's if you have I to the 4th times I to the 3rd like this, then you add them. If it's the base to a power times the same base to a power, you add them. But when it's a power raised to another power, you... So I to the 4th to the 5th means I to the 4th times I to the 4th times I to the 4th times 1, 2, 3, 4, I to the 4th. 5 of those. And then what does I to the 4th mean? It is 1, but what does I to the 4th mean? Like when you raise something to the 4th power, what does it mean? I to the 4th power means you do what with I?
You take the product.
I times I.
4 times, right? So there's 4, there's 4 more, 4 more, 4 more, 4 more. If you add, if I listed them all out, I would have 20 i's multiplied together, which is what I to the 20th means. So I'm kind of going back and explaining this property right here, but I to the 20th can be broken into I to the 4th to the 5th. So the shortcut for, like, if you have a power being raised to another power, you multiply those exponents together. So that's I to the 20th. So what is I to the 20th equal to then? If you have, what's I to the 4th?
1,
What's 1 to the 5th?
5.
1 times 1 times
Oh,
1
1,
times, it'd be
sorry.
1, right? So this is just 1. Because it's a multiple, 20 is a multiple of 4
Yes.
with no remainder, right? Sam, you understand what I'm saying? Did that go into your brain? What did I just say?
I have no idea.
Okay. Called
Like,
you
you're
out.
honest.
I to the,
I know how to go.
so 20 is divisible evenly by 4. So that means there's no remainder, so there's no leftover i's. So it's going to be you can write that as I to the 4th to the 5th power, and that means 1 to the 5th power, which is just 1. What about I to the 23rd? It is not -1. How many? Okay. Does 4 go evenly into 23?
No.
No. So I can write I to the 23rd as I to the 4th to the 5th. That's I to the 20th. How many more i's are missing from that? 3. So this is I to the 3rd. So what is I to the 4th to the 5th power? 1, right? It's I to the 20th, but and then if I add that I to the 3rd, it's I to the 23rd. So this part is just 1, so I don't really need to even think about that, because 1 times anything is just that thing. I to the 3rd equals negative I. Negative I, is that what you said?
Can't see the dot. But I said
It's a negative I. Okay. So doing like I to the 201st power, you wouldn't want to list it all out to the 201st power. That's just too much to do. Oliver, do you know what that would be? Think of,
I
how did you get that?
divided for the remainder by 4 with the remainder.
It was, so when there's a remainder of 1, so it's 1 I. Nate, 201 is not divisible by 4, right? But 200 is divisible by 4?
Yeah.
It's like, think dollars. If you had 200, there's
200 divided by 4 is 50.
yeah, yes. So there's 1 remaining. So if I do 201 divided by 4, I get 50 with a remainder of 1, right? That's not 50 that looks weird. 50 remainder 1. So when the remainder, when you divide by 4, is a 1, then it's going to be 1i. if the remainder is 3, it's going to be the same as I cubed. If the remainder is 2, what is it going to be? Negative 1. Yep, because I
just
squared.
remembered it by where it was in the sequence. If it's got remainder 1, then it's the first one the same.
Yep, if it's remainder 2, it's going to be the same as I squared. If its remainder is 3, it's I cubed. What if the remainder is 4?
It's I.
No,
Is that 1?
it'd be 1 because if it's a remainder of 4, then it means that 4 is going to go into it evenly because there can't be a remainder of 4, right? Because we're dividing by 4. So another way to think of this number 16 is I to the 200th can be written as I to the 4th to the 50th power. Comprende? Times an extra I. Because this is I to the 200 because you multiply the 4 times the 50. Again, are you following what I'm saying?
Yes, I'm going.
Okay, so then that's I to the 200th right here, but I need another multiply by another I because I need it to be 201. Okay, so you guys do 17, 18, 19, and then we'll go over how to graph complex numbers. Go over how to graph complex numbers. This up right below what we were just working on. You guys, this is actually pretty simple to do if you know how to graph ordered pairs. So really what you're going to do is you're going to look at this and the what we normally call the x-axis we're going to call the real axis, and the y-axis is going to become we're going to call it the imaginary axis. And graphing complex numbers, the whole it's pretty easy to do, but it's the basis behind a lot of Einstein's work, a lot of anyway, theory of relativity and all that. So when you're graphing this, you can almost think of this as like an ordered pair. You're going to go in the horizontal direction, by the real part, and in the vertical direction, like in normally the y direction, by this amount. So you're going to go to -3 on the real axis and 0 up or down on the y-axis, which is now called the imaginary axis. So for what am I going to do for b, where it's just -2i? How far do I move left or right?
-2.
Because this can be written like this.
Oh, you don't write this thing. And then you move down 2I on the imaginary.
Yep, you're just going to go down 2 on the imaginary axis. So you should label this B, and you should label this one A, and then you guys go ahead and do C and D and label them. What time do we end here? 12:50. Okay, Porter is going to graph D. Sam just graphed C, so you can look at that one, and then D is, yep,
So
-5 on the real, and then how far down on the imaginary axis, which is like
1.
Yep. Throw that point down.
It's
It's not working. I don't know why. Huh. Interesting. It should work now. So you can label that D. All right. Okay. Let's see here.